composite functions. What is a composite function? Let me give an example. Say, let me give an example. Y is equal to x plus 5. Let me rename it as f of x, f1 of x, or simply I'll write f of x is equal to x plus 2. This is a function. Now I'm going to give another function, g of x is equal to say x square. Now I need to combine these two, and I want to find out f of g of x. F of g of x. So that means, where is our input? X is the input, right? So here, what is our input here? The function is x square. Now, if I want to find f of g of x, I'm going to write first g of x in this place. Okay. In the place of x, we are going to replace here x square. Then what is f of x square now? F of x square is actually x square plus 2. But effectively, this is f of g of x. Okay. So to make it very clear, maybe I'll tell you the other one, g of f of x, the reverse direction. Will it be same? Let's see. In the place of x, we have f of x, so we're going to write this x plus 2. Now, in the place of x, we have x plus 2, so g of x will not become x square. In this case, it will become x plus 2 whole square. So we know x plus 2 whole square is not equal to x square plus 2. They are not equal. So these are the examples for composition of a function. Let us see pictorial way of understanding composition of two functions. Okay. So yes, we are coming to the end of the session. So you can see, maybe I will give a different diagram. Easier way to understand this. With the mapping, I can show you. So for composite functions, at least we need to have 3 sets: A, B, C. So 2, 3, 4. A, B, C. And then maybe, yes, I'll have some symbols. And then, yeah. So so now see here, let this be A to B be f of x and B to C be g of x. Okay. Now what is f of 2 is A, and g of A is, you can see hash symbol. Now if I want f of g of A, so do we have, sorry, I am going to go for g of f of 2. So what will happen is, we know what is f of 2. We can directly apply f of 2 is VA, and if I apply the g of A, we get the hash. This is how the composite functions work. So right, so if I want to get the reverse direction, I need to have a reverse relation also. So I'm going to show only one-way direction from f of x to g of x. Okay. So yes, you can read these pointers quickly. I'll explain this as well. First, we need to understand what is odd function and what is even function for this. All right. Suppose f of minus x is also equal to f of x. Such a function is called even function. Then what is odd function? If f of x is equal to minus of f of x, then it is called odd function. Okay. Please keep it in your mind that a function can be neither even nor odd also. It is not like natural numbers. If the number is not even, it must be odd. Not like that. A function can be neither even nor odd also. Example for even function is, say, f of x is equal to x square. So if you put minus x, that is f of minus 1 is also equal to f of plus 1. That's an even function. Okay. If all the variables in the polynomial has even power only, that will definitely be a even function. Okay. Similarly, f of x is equal to x cube is an odd function because f of minus 1 is minus 1 and f of plus 1 is plus 1. So that is an odd function. So, but look at this example, x square plus x square, x cube plus x square, which is a function. This is neither even nor odd because if you substitute, it will not give you exactly negation of another function, right? So this is neither even nor odd. Just to keep in mind, a function which is not even need not be odd. It can be neither even nor odd also. Okay. So quickly remember these pointers which will help us in understanding some of the question. So when it comes to composite function, okay. So let me erase this. When it comes to composite function, if there are two functions, suppose f of x and g of x. So the table, I can write a table like this. If f of x is even and g of x is even, then f of g is also going to be even. If f of x is odd, g of x is odd, then f of g will be odd. Okay. Similarly, you can change the direction if you want, and accordingly you can write the order also. If f of x is even and g of x is odd, it says f of g of x is still going to be even function. So it's very easy to remember, just like a multiplication, right? If f of g is odd and g of x, f of x is odd and g of x is even, the function is still an even. It's very easy to remember. I'll tell you, if there is one even number also, the product will be even only, right? So if there is no even number at all, the product will be odd number. So if both the functions are odd, the composite function will be again odd. If at least one of them is even, then the composite will be still even function. So this is easy to remember, just like a multiplication. Okay. Yes. So quickly going to the questions. So we have come to the end of this. So I'll solve two questions and then I'll answer. If there is anybody has any doubt, we can discuss as well. Okay. So let's quickly solve some questions on this section. We have enough questions here, but let me discuss some of them. So there is a function. Let me choose some interesting questions. Yeah, let me check this. The question says write f of g. Write f of g if the function is defined from R to R. These notations are important, real numbers, okay? Where f of x is given as 8x cube and g of x is given as x power 1 by 3, that is cube root. So we want to find f of g of x. So what is it? So let's keep function f. Just first let's open this part, g of x. So I'll write x 1 power x power 1 by 3, right? So wherever x is there, we're going to write 8x power 3. Now in the place of x 1 by 3, we're going to keep 8, which is a constant, and we're going to apply that. So what do we have in the place of yes, so 8 in the place of this, we are going to write this, and we're going to put this function. So we are going to cube this part only, right? So this is 1 by 3, and we're going to cube this part. So what do we get is 8 remains as it is because this function already has 8 constant. So 8 will not be changed. Only the cube root is applicable for the given function. So what do we get is 8x as well. So the root will be cancelled. Cube root will be cancelled to 3. Right? Yes. Quickly, one more question, and then I'll come to your queries. So we need to spend at least 15 minutes on the questions. Okay, so let me take an interesting example. Yes, finding inverse of a function, right? So That's very important. So we will have questions on finding inverse of a function. So let me take the second optional question here. I'll rewrite again. The question says, if f of x is equal to 4x plus 3 divided by 6x minus 4, where x is not equal to 2 by 3. You must know why. Because if x is equal to 2 by 3, this will become denominator. Show that f of x is equal to x. Okay, and also find the inverse. So let us not, let's just find out f of x is equal to x or not. So what is this? Function of 4x plus 3 divided by 6x minus 4. Now what I should do is I should replace wherever x is there. I should replace the entire expression 4x plus 3 divided by 6x minus 4 plus 3 divided by 6 times this part. Again 4x plus 3. Let's observe and answer because we don't have to solve this completely. If you solve this, what we get here is we'll be having 4 multiplied with this 16x plus 12 minus 18x minus 12. So plus 12 minus 12 cancels. I'll end up with 34x. Okay. The denominator, what happens is 24x will have, yes, 24x plus 18. Yes, again I'll have 20 minus 24x, that will cancel out and I'll end up with minus 16. So it will become plus 16. So finally that will become 34x by 34. So they will cancel out. We end up with x. That means I can show that f of x is equal to x. Right? To find the inverse, let me take a better example so that you can easily understand what is inverse. Say, first, to find the inverse, you should know that function should be invertible. That means what? You cannot take random example. You should take a, what kind of example? The function should be bijective. Okay, so whenever you want to find inverse of a function, let me talk about inverse of this function. Okay, so let us rename it as y, 2x plus 5. First, let's check, is it 1 to 1? No doubt it is 1 to 1 because every value of input of x will give you one value of y only, right? Is it onto, if it is defined on the, maybe I'll say whole numbers. This is defined on the whole numbers. It is very important to understand on what set we are defined on the whole numbers. Is it onto, defined on the integers? Let's keep it as integers. It is going to be onto, for every number will get integer only as output, right? So it is onto as well. Now I want to know the inverse of this function. So what is inverse of this function? First rearrange this like find x in terms of y. Okay, so what I got is this much. Right, now you please replace all this y by x, that is its inverse. So it's very simple. Okay, so this is our inverse of the given function. The given function is f of x, which is 2x plus 5, whereas inverse is, you can see some logic here if you can understand. So here plus 5 is added, we are subtracting 5, and here 2 is multiplied with the x, here 2 is dividing the entire function. Okay, that's the inverse of a function. So if you can try to find the inverse of this function, please try it, practice it. Right, so I have 10 more minutes to have a discussion with you. Okay, so if you have any questions or if you have any doubts about what we learned right now, you can always tell me. I'm waiting. I'm now going to look at your chats and see if anybody has any queries.